Hello friends, today we will solve some of the problems in complex numbers. As we have defined in the last class different varieties of definition, today according to the definition I will try to solve some problems. First problem, that find the domain of definition of the function f of z. Now first problem, you are given f of z is equal to 1 by z square plus 1. You have to define for what values of z the function is going to define now. So what do you mean by domain? Domain is set of all values of z where the function is going to be defined. Here this function is going to be defined, here it is, whenever see the given function is of rational form here. So anyway numerator is not equal to 0. The denominator part you have to observe. The function is f of z is defined for all the values where z square plus 1 is not equal to 0, or that means here z square is equal to minus 1, or that is z is equal to plus or minus root minus 1. That is nothing but plus or minus, as you know that root minus 1 is equal to I. So therefore the domain of the function in this particular problem is set of all values of x comma y, or set of all values of z which are not equal to plus or minus I. Apart from this, everywhere the function is defined. Let me take another example, that if f of z, I will take another example here, f of z is equal to, second example, argument of 1 by z, then you find the domain of this function. Now before that we have to simplify 1 by z. As we know that here z is equal to, we know that, see let me write, we know that z is equal to x plus iy. Therefore what is 1 by z? 1 by z is 1 plus xy. As you know that we are not preferring the I imaginary term in the denominator, we are going how to remove this here, that is by taking the conjugate of the denominator. You know the conjugate, I have explained you in the first session itself. So negative, you take the negative of imaginary part, right, minus, I mean minus, just change minus in the imaginary term and multiply numerator and denominator as you are doing in real number rationalization form. So which is equal to x minus iy divided by, you know that this becomes a plus b, a minus b, right. So it becomes what? X square minus iy square, which is nothing but x minus iy divided by x square minus I square. You know the value of I square. I square is how much in complex number? Minus 1. So minus into minus here, it is plus 1, it is going to be y square. So it is equal to what? See, x by x square plus y square, separating in u plus iy form or keeping in u plus iv form, which is nothing but minus, it is I y divided by x square plus y square. Therefore in the given problem, argument of 1 by z, you have simplified or you have found out what is 1 by z. 1 by z is how much? Nothing but this here. Now they are given to find domain of argument of 1 by z. So therefore what do you mean by argument? Argument is an amplitude or angle that the number which makes an with the positive direction of x axis. So, now here argument is how we are going to define, it is in terms of theta. Theta is equal to what? Theta is equal to tan inverse of y by x. I mean here it is modulus of y by x, that is here. Now, this is equal to here tan inverse of x means y means what? This term, this is going to be minus y by x square plus y square divided by real part x square plus y square. This one simplification, it cancels that and it gives you this is equal to tan inverse of modulus of minus y by x, or that is nothing but tan inverse of modulus, you know the property, it becomes y by x. So, what on simplification you have got argument of 1 by z is how much? Tan inverse of 1 by x. Now, decide the domain of the function, where now you know that where the function is defined, set of all values of x where this is not equal to 0, even though this is equal to 0 you can define it here. So, therefore, domain is set of all values of x comma y, which is, see, this is going to be belongs to R, and or this is nothing but set of all values of z, it belongs set of complex number. So, the whole in the whole set of that complex number the function is going to be defined. So, that is what the domain of the given function. So, this is what the two problems that we have observed in domain of the function. Now, another problem, another variety of problem, that is, see, express the given function. I am writing in short it as fn, I mean function f of z is equal to 1 by z in that two form, one u plus iv form and second one it is polar form. Yes, as you know that 1 by z is equal to, now given here, given f of z is equal to 1 by z, that is as we have did in another last problem, 1 by x plus iy. How to remove that this imaginary term in the denominator? Taking the conjugate of the denominator multiplying numerator and denominator term, which is equal to what? X minus iy divided by x square plus or minus a square minus b square, which is equal to here x minus iy divided by x square minus I square is minus 1, minus and minus it becomes plus here y square, which is equal to what? X by x square plus y square, that this is u term plus now here minus y divided by x square plus y square, which is nothing but, see, this you observe that this is in, or you can write it as I, you can take that here. So, that is nothing but I will write here, okay, this is equal to here, it is x by x square plus y square minus, now the term is minus, this I have multiplied, it becomes minus I here, which is nothing but y by x square plus y square. See, this is nothing but u plus I times v. So, this is what you can keep 1 by z in the u plus iv form. Similarly, second form is given here, polar form. So, polar form, as you know that I have explained in the beginning, you can express complex number in three different forms. One is in Cartesian form, second one is in polar form, third one is in exponential form. Okay. Now, as you know that, here it is, as we know that in the last class, z is equal to x plus iy, and this is r into cos theta plus I sin theta, this is in polar form, right. Now, you just substitute this value here and simplify, we will get in the polar form. Let me observe this in the next class. Thank you.